Today I will present about Herform, and my name is Junil Yu. Today we'll talk about hull proportions and general approach of lines drawing. Before we know hull proportions, we need some basic contents: the beam, depth, and drift. This picture is about draft and depth and breadth. Breadth means breadth is same as beam. Major important hull proportions is length per depth ratio and length per beam ratio and length per depth ratio and beam per depth ratio, and it means block coefficients per length depth ratio. Length depth ratio is very important in structural design, and length beam ratio is important for maneuverability, and it means driving the ships. Length per draft ratio is important for bow slamming when there's some bow slamming damage during severe weather, and bow slamming means when ship is fluctuating by some big waves. Bow hit to the surface, and that's the bow slamming. Beam draft ratio is important for stability and wave making characteristics. Wave making is when the ship goes front. Behind the ship there's some make some waves, like this picture. This is wave making, and nowadays they use for optimize the Herform with some programs. Think about wave making and fluctuating of ships. This is a graph of performance and length per beam ratio. In this picture, tanker and bulk carrier has speed of 15 to 17 knots, and cruiser and ferry is 20 to 23 knots. When the speed is higher, this is resistance. Resistance is much more have big difference in length per beam ratio. So when the ship is very fast, length per beam ratio is more important than slow ships. And this is a diagram for block coefficients and Froude number. This picture. This is a historical data of Froude number and the block coefficient. This is the equation, and when each ship has very different speed, so for slow ships needs more block coefficient. So we can design the ship with speed and block coefficient and Froude numbers. Second thing is general approach of lines drawing. The general approach of lines drawing is mode loft. It is hard to draw the three-dimensional ship to flat ship, so we need to. It is very hard, so we need some ways for drawing. So this is mode loft, and it's the rear size drawing that we should draw the same as size of ships. This is a picture of mode loft, and when you draw the mode loft of ships, they draw it by rear size. But nowadays they use some programs and others. And with this mode loft, they make this shape of steel or wooden structure. They collapse it, they make some ships with these structures. For big ships, it takes very long time, and ships coming this shape. So with mold loft, they can make some parts of ships, and they make some ships. And this is hull form draft of hull form. This is a body plan draft. Left and right is different because we have back side and front side of shape, but shape is symmetric, so left side is front, left side is back, right side is front of the ship. And this is next slide. So body plan has 4 body lines are at right, and after body lines to the left. Each draft draws by the depths of water. And this is water lines and bottom lines. Water plane is half breadth plane. This means half breadth plane is upper side of boats, and shear plane is side of the boats. This is offset table of this ship's shape. X is XYZ. X is longitudinal distance from the ships, and Y is transverse distance, and Z is vertical distance of ships. I'm done, but it's pretty fast. Have any questions?
Can I see the previous slide? So when I was a student in naval architecture department, we had a special class for drawing, line drawing. So this one is given to students. We start from here and then draw the lines drawing out of this table. You can think about how can we do it. Can I see one step? Yes. So this one, this is you can convert that table into this body plan first. Because that body plan is something like with this table at each stage. This is a station. Station means this one, longitudinal sections. Right? This is a station lines, and then this is a water line. So each water line there is a breadth of station. Right? Can I see go down? Right. This one is say station numbers. Starting from probably this one is probably usually it starts from AP back side as a 0 AP, and then 20 or more stations, and then water lines, right? Water line, each water line, right? And then this is the breadth at the station. Once again, can I go up? So each station and each water line, this is a water line, right? Water line. There is a, say, 4 stations, say 5 for the water line 1, water line 2, there's breadths, right? Values. So you can use that table, then you can get some points at each station and what line, right? And then you need to have a fitting using a very flexible plastic. There is some trick. But anyway, then you can draw these other lines. So there is some. Okay, that's good. So we can go on to next presentation.